Okay, what we are going to do now, we are going to do the computation of the peak discharge. The computation and the peak of the peak discharge and hydrograph using MSMA. How to compute peak discharge or hydrograph in MSMA. So the way that we do it is this. I prepare an illustration here. So you look at this illustration, it basically summarizes up how you do the computation, how you compute the peak discharge in MSMA. Basically, there are the method is already covered inside MSMA. But the problem in MSMA is that all this information is scattered everywhere in different chapters. So I try to put everything into one diagram to explain what MSMA is trying to tell us. Right? So if you read MSMA, it's not stated at one single place, but it's all scattered around inside MSMA, different chapters. They try to tell you this information. Okay, according to MSMA, if you want to compute the peak discharge for area less than 0.8 kilometers square, you use the rational method. You use the rational method for area less than 0.8 kilometers square. For area above 0.8 kilometers square, you must use the hydrograph method. The hydrograph method will compute the peak discharge and also the hydrograph. The hydrograph is a time distribution of the discharge over time. Okay, rational method. What is rational method? So this topic we cover in workshop number 1. The rational method computes the peak discharge, but it does not give you the hydrograph. It does not give you the hydrograph. And it's used only for area less than 0.8 kilometers square. Less than 0.8 kilometers square. This is the design method. It's not for analysis. It's a design method. It's based on a simple empirical method. Okay? This rational method is based on a very simple empirical method. Whereas the hydrograph method, it gives you the peak discharge as well as the hydrograph. Now, this hydrograph method, there are two. Basically, there are two major types of hydrograph method. According to MSMA, these are the two common methods for computing hydrographs. The first method is the time area method. This one we're also going to do in workshop number 1. Another type of method is called runoff routing method. Runoff routing method we do in workshop number 2. So what is the difference between time area method and runoff routing method? What is the difference? What is the difference between the two? The assumption in the two models is slightly different. The assumption is slightly different in the two methods. The time area method is based on convolution of rainfall excess hydrograph with the time area diagram. And this is suitable for design only. It's not for analysis. Okay? So same like the rational method. This is also a design method. It's not recommended for large catchment because it is too complicated if you have too many isoclones. Because in the time area method, you use isoclone. Isoclone is a graph of time of equal travel to the outlet. Okay? So it's not suitable. And the method is a little bit complicated. You must understand the theory first before you apply. It's a little bit complicated. And moreover, the method cannot allow you to route it through a detention basin. You must use a different software or spreadsheet to do that. Okay? You cannot route it through a detention basin directly. You must use another software to route it. But in the case of the runoff routing method, is different. You can route it through directly through a detention basin. Right? Because inside that they have modules for detention basin routing. So the runoff routing model is based on the physical model of the rainfall and runoff routing process. Based on the physical model. It's suitable for design and also for analysis. Okay? It's for catchment of any size, whether it's above 0.8 kilometers square or it's below 0.8 kilometers square, above or below. You still can apply it. And this method, you need to calibrate the historical data using the rainfall and the stream flow data to calibrate the model. And you can model the changes in the land use. And you can route the hydrograph through a detention storage. Because as I said just now, inside there they got a model for routing through detention basin. So everything is done inside the software. And the software is easier to use because it has a very user-friendly graphical user interface, GUI. And you can interface it with a hydraulic model. For example, Hydrographs. You can interface it with the Hydrographs. And this is a free software, the HMS model, in workshop number 2. By the way, this software is also recommended in MSMA. All the 3 of them are recommended. So this is just a quick summary of the method available according to MSMA. See, MSMA specify that for area below 0.8, you must consider using the rational method. For above 0.8, you must use the hydrograph method. Okay, so that's all. The comparison of how the different methods for computing the peak discharge according to MSMA.